Alright, welcome to lesson 2.5, the Pythagorean Theorem and the distance formula. Doesn't say it there. We're going to be learning about these two things and how they are related. It's actually quite beautiful. So, what is the Pythagorean Theorem? The Pythagorean Theorem is something that we use to find the missing side of a right triangle. And let me emphasize that this can only be used in a right triangle. Alright? The Pythagorean Theorem, you might remember this from middle school, a squared plus b squared equals c squared. And the most important thing here is you must always put c as the hypotenuse. The legs, it doesn't matter what order you put them in, the c must always be the hypotenuse. Now what is the hypotenuse, you might be asking? It's the longest side and it's across from the 90-degree angle. So if you're ever wondering, well, which one's the hypotenuse? All you do is start at the right angle and draw a line across. That is always the hypotenuse. So let's look over here. If I was trying to find the length of AC, and I knew this was a right triangle, I'd use the Pythagorean Theorem. Well, AC is the hypotenuse because that's across the 90-degree angle, so I know my leg is 3 and my other leg is 4. Alright? Since I want to find what AC is, I always like to put an X for the thing that I'm looking for. Let's put an X here. Okay? Well, all we got to do is do the math now. So 3 squared is 9. Plus 4 squared is 16 equals x squared. 9 plus 16 is 25, which equals x squared. And then you might not know this, but to undo a square, to solve this equation, you have to take the square root. So if x squared, to undo that, you take the square root. That is the last step you have to do. So that means x is equal to the square root of 25, which is 5. So that means AC is 5. And that's it for the Pythagorean Theorem. So let's try a little bit more of this, okay? Let's give another example of this. In this case, we want to find the length of DO, alright? So let's put an X there. Alright, when you're looking for something, it's good. X marks what you're going to be finding. So in this case, the first thing I do is, what is the hypotenuse? Which one's the hypotenuse? Well, if you're wondering, 8 does look like the longest side, but also you could always just draw your line across, and sure enough, this is the longest side. Alright, now we just have to plug into the Pythagorean Theorem. It's a right triangle, so we can use the Pythagorean Theorem to find the missing side length. Well, we know that one leg is 5, the other leg is x, and that our hypotenuse is 8. Okay? Well, let's solve this. 5 squared is 25. Plus x squared is, well, x squared equals 64. Let's subtract 25 from both sides, and we get x squared is equal to, well, when you subtract those, you should get 39. We take the square root now, alright, and when you take the square root, you actually see that it's not a full number, alright, it's actually just the square root of 39. So we want to write this in two ways. One, let's leave it as a radical. Leaving it as square root of 39 is totally acceptable. But you could also leave it as a decimal. So let's put that in. We have two possible answers here. We could say it's the square root of 39, or put it in your calculator and see what you get, which I will try right now. That is 6.24. It keeps going, but we're going to do it to the nearest hundredth. If I ever ask you to do it in decimal, I'll tell you how many decimal places I want it to. Okay. The next part of this lesson is to figure out, how do you know if something is a right triangle? So here you have the two triangles that look like right triangles, but how can you figure out if they are or not? Well, the way you could do it is actually plugging into the Pythagorean Theorem. Alright? And if it works, if both sides equal each other, then it is a right triangle. So let's give the first one a shot. Well, we know our longest side is 9, so that's going to be our hypotenuse. Alright? So let's put that over here. Okay? And so our two legs are going to be 6 and 4. Well, let's see if this equals each other. So 6 squared is 36, 4 squared is 16, and 9 squared is 81. 36 plus 16 is 52. Does that equal 81? Well, no. So this is not a right triangle. Well, let's try this guy right here. Alright? Well, the longest side here is 13, so we'll put that in for our hypotenuse, and we get 5 and 12 for our legs. That's a 13. Come on. All right. 5 squared is 25. 12 squared is 144. And 13 squared is 169. All right. 25 plus 144 is 169. This is 169. And so, yes, this is a right triangle. So this is yes. All right, that is a right triangle. Right triangle. Okay, let's move on to the next part with the distance formula. For the second part of this lesson, we're going to be finding the distance between 2 points. And I know what you're thinking, how is this even related to the Pythagorean theorem? Well, I'm about to show you how it is, and it's going to blow your mind. So let's say I want to find the distance from A to B. All right, basically it's this line right here. I want to find the length of this line. Well, how am I going to do that, right? Because you can't just count across. These aren't 1 unit each, so you can't do it that way. Well, what are we going to do? Well, I'll show you. What you could do is create your own right triangle. And what I mean is by dropping a line down like so, okay, and dropping a line over here. And this creates a right angle at this corner. And now I have a right triangle. The cool thing is, by doing this, is that you could actually find the lengths of these two sides. So the length of this leg, 1, 2, 3, 4, 5, 6, 7, 8, is 8. And the length of this, 1, 2, 3, 4, 5, 6, is 6. So now I know I have a right triangle with legs 6 and 8. And the distance between the 2 points is our hypotenuse, x. Well, now that I have a right triangle with 2 sides and a missing hypotenuse, I could just plug this into the Pythagorean theorem. So A is going to be 8, B is going to be 6, and our hypotenuse, and that's always going to be the distance between the 2 points, is our x. Let's do out some math. 64 plus 36 is equal to x squared. Add these together, we get 100 is equal to x squared. How do we get rid of this squared? We take the square root, and we get x is equal to 10. Beautiful. So that is the distance from A to B. This would be side length 10. Okay? And let's be fancy about it. AB. So that's how this question is done. So basically we just use the Pythagorean theorem, but you know what, there's a shortcut for this. There's actually a formula, the distance formula, that is derived from the Pythagorean theorem. So a squared plus b squared equals c squared. Well, what we did here was to find the length of one leg, we could just subtract x1 minus x2. So if I subtracted this x coordinate from the x coordinate right here, that would be 8. And I could also subtract the y coordinates. So y coordinate here from the y coordinate here, y1 minus y2, and that would tell me the distance, the length of this leg. And that would tell me what the distance is. Now, if you notice here, this is c squared, and this is just d. So to get rid of the squared, you actually have to take this whole square root right here. All right? So x1 minus x2, that's one leg squared, plus y1 minus y2, that's the second leg squared, which equals the distance, and we take the square root of the whole thing, because that's how you get your final answer. This is the formula. You always want to write this down before using the distance formula. Why? It's just good habits. Just good habits. So let's give it a shot. Let's find the distance between 2 points. We're going to use the distance formula, and we're going to do graphing. So what is the distance? What is the length of the line segment whose endpoints are -2, 4, all right, and 5, 1. All right, that we want to find this length. Well, the first way we could do it is by using the right triangle method, using the Pythagorean theorem. So let's make this into a right triangle. Okay, we got a nice looking right triangle right there. We could count our side lengths. This is 1, 2, 3, and this is 1, 2, 3, 4, 5, 6, 7. All right. As always, the distance between 2 points is going to be our hypotenuse. We plug it into the Pythagorean theorem. 3 squared plus 7 squared equals x squared. Let's do out some math right now. 3 squared is 9, 7 squared is 49, and that gives us x squared. 9 plus 49 is 58, which equals x squared. Get some square roots up in here, and we get x is equal to the square root of 58. Now you could put this in the calculator, but you know what? It's not a perfect square. You'll get some weird decimal. Let's just leave this as our answer, the square root of 58. Okay, for the second part, we're going to use the distance formula this time and see if we get the same answer. These two methods should get us the same answer. So step one is always write out the distance formula. It is the square root of x1 minus x2, all right, squared, plus y1 minus y2 squared. Now let's label these coordinates, x1, y1, x2, y2. Ready to do this? I am. So, we take the square root. What we're going to do is now plug everything in. x1 minus x2 would be negative 2 minus 5 squared plus y1 minus y2, which is 4 minus 1 squared. Now this should be giving the length of each leg. Well, d is equal to negative 2 minus 7, minus 5 is negative 7 squared, plus 4 minus 1 is 3 squared. Now I want you to notice here, we got negative 7 and 3, and 7 and 3. Alright, those numbers are the same. Now it doesn't matter if this is negative, it's still the length of the side. So you see, these are actually the length of each leg. Let's keep rocking out right now, okay? Keep rocking. The d is going to be equal to the square root of negative 7 squared is 49. Now I want to be clear here. Any number squared is always positive. So if you do this on the calculator, please make sure that you put parentheses around that. If you don't put parentheses, you're going to get negative 49. All right, negative 7, and you put the square, you get negative 49. That's incorrect. You can never get a negative when you square a number, square a negative. It's always positive. So please, please, please put your parentheses around in the calculator. 49 plus 3 squared is 9, so d is equal to the square root of 58. And it looks like, yet again, it worked out. Our two answers are the same, using two different methods, which were really the same method. So there is a deep relationship between the Pythagorean Theorem and the distance formula. They're actually pretty much the same exact thing, written in two different ways. Alright, that's it for this lesson. Don't put boogers on your shoes or on your clothes, because then your mama's got to clean it. She's going to be pissed.